Okay. All right. For those joining this live stream, we are looking at error handling in Wolfram language as one of a series of meetings dealing with this issue. Okay, Connor, can you remind us where we got to last time?
So we're talking about error handling, and in particular, we're talking about, at least in the first phase of this project, error handling in sort of development projects. So not error handling down in package code, for developers who are being careful about how they do errors. We did talk a bit last time, and we'll perhaps get into this time about adding error handling to sort of code that doesn't have a lot of existing error handling infrastructure. But we're more going to be focused on the developer use case of people who want to handle their errors in a careful and deliberate way. How can we help them along with that? And in particular, the context is we're thinking about how a lot of internal projects do error handling right now in ways that are kind of have a lot of duplication of effort. So we talked a bit last time about some concrete ideas about new functions related to error tagging, changes to our failure representation, how those are created, and then functions for kind of raising or throwing failures and then catching them and handling them in a more programmatic and more ergonomic way. Some of the things that we started to get into last time.
Hold on. Mm-hmm. So what we're not talking about, and what is a future discussion, is you've got a WFR function and you've written it to follow the code path you immediately could think of, but there is an error code path, and we need to have a nice, clean way to, deal with, oh, this function was supposed to return a number and it's not, make that an error path type thing. But that's not what we're talking about here. We're talking about a different thing of crunchier, larger scale, industrial type development.
Well, I would argue that the phase, I don't know how this has been reorganized now, but the phase 4 stuff, I think would maybe also include that, right? That basically if you have certain built-in functions or some mechanism for having built-in functions, there are exceptions of this kind, then that also sort of often handles, the sort of automatic error path. I mean, if you just add one handle to the outside of the function,
mm-hmm.
But yeah.
What you mean this is the function. This function usually returns numbers. Tag it that way. Is that what
no? I mean more of like, I think that usually where naive functions go wrong is not that it returned a string instead of a number, and what a surprise. It's usually that some function in the middle returns a string instead of a number.
Absolutely.
and then it's a cascade of problems. But then of course, whatever function, if something returns a string instead of a number, and then the next thing is called to I don't know, dot or something, and dot freaks out because you gave it a string, then
well, that's a bad example because dot wouldn't, but yes.
Okay, fine. Well, not dot. Net train. You
right.
Give it an integer. It's a single argument, and it freaks out. Then this is sort of the issue. If you imagine that net train threw an exception or through some sort of easily catchable thing, maybe just like a message, then which it does, then you can handle that. So yeah.
And just to frame that a bit, so because there are related questions, one of the things that I put on this kind of summary of the meeting that we want to talk about is categorization of messages. We originally thinking about this mostly in terms of, suppose you had a function, like somebody wrote a piece of code like this, right? The careful programmer would write this if statement before they go ahead and do read string, right? They're going to check for this potential failure condition, and they're going to raise their own error code to indicate what went wrong. That maybe the less careful, or the person who's still kind of in the prototyping phase, they're just going to call read string without checking. And read string will issue a message if this file doesn't exist. And by having a mechanism by which we can convert messages into errors at the time they occur, stop the kind of cascade of unevaluated, whatever failures before it starts. We can add robustness to code that wasn't written with this explicit error handling by having this outer handle that would catch, would check for those messages and kind of transfer control flow at that point.
As I've said many times, mm-hmm. I strongly believe that we should have messages that are off by default that can be checked this way.
Yeah, and I think that's
yeah. Go ahead.
And I think that's something we're thinking about. I mean, obviously, it's a hairy problem, but certainly that's something that will be easier to speak about in a concrete way. Like, I have a message that's off by default, but in a particular situation, I might want to handle it and opt in for a particular scope, say.
But by the way, has anyone done the actual benchmarking to know if off by default messages have a performance impact? I mean, like, of course, if they're only happening on like kind of expensive operations like packing and unpacking a packed array, I mean, then that's kind of okay. But if they're happening on cheap operations.
Yeah, well, we need to check that. Then there may need to be some new mechanism to deal with off by default messages. Yes, that's a reasonable question.
Yeah.
Okay, but so your basic design here is this handle function that kind of cleans up afterwards, saying if there was a message, then do something. Is that correct?
Just to be clear that we're on the same page. So handle is sort of like check in that it well, maybe okay. Let me say this a different way. Handle of a message. If you write in the syntax is rough, so we're just going to speak roughly for now. But if you have something like a rule that handles a particular message in your handle, it will transfer control flow. It'll stop executing at the point that message is issued or is raised, and transfer control flow to the handler, and it won't go back to the code that message came from. So it's a way that
so
the
it's
message
like ConfirmQuiet, right? It's
yeah.
Yeah.
What's the difference between this and ConfirmQuiet?
Well, it handles various things that are not just messages, right?
Quiet
Yeah.
does.
What was the idea of what handle?
Oh, handle does.
Yes.
No. ConfirmQuiet.
No, right. But ConfirmQuiet only, so, right, ConfirmQuiet, first of all, only detects messages as opposed to other things. And second, ConfirmQuiet is really for use, right? Like if you have an enclose, so okay, there's two things you can write with ConfirmQuiet. The sort of intended use is you do enclose, and then you in the middle of your code, you make a call, and you know that this call is a little sketchy. So you say ConfirmQuiet around just that call. And basically if that call fails, then it will detect it. But what a lot of people end up doing, because this is kind of similar anyway, is you just do enclose of ConfirmQuiet, and then all your code goes inside of the ConfirmQuiet. And really, this should be a separate function. I mean, really, this is the thing that check would like to be, maybe. But because check isn't that, then you can get around it by using ConfirmQuiet.
Sorry, say again what you need, the case that you need.
The case where you just say enclose of ConfirmQuiet of blah, where blah is a giant piece of code. And this is basically check that fails immediately when a message is thrown.
Okay, which is the same as Connor's handle thing, correct?
Yes.
Well, it's a subset of the handle thing.
What else does the handle do?
Yes, I think the point is, when I suggested this handle function, is that it should be, I mean, its primary purpose would be to handle exceptions that were raised. But since we have a lot of different things that catch things and not others, I thought that maybe we can have something that can be used to act on anything that happens, and that would be messages turned into exceptions, or even abort can be handled that way, or arbitrary signals or memory exceptions, whatever. So it's intended as a kind of new catch-all thing that can be highly configured, and the list of handlers declares which ones it actually acts upon.
Okay.
I also think that there is a way to add to this picture, in that, in addition to considering handle as a kind of final stop of your journey of your various signals like exceptions or aborts, you can also think of it as a sort of a transformer, which in general can transform one type of signal into the other. So I find it personally more useful to think of handle as a transformer with, of course, 90% of its functionality being used mostly as a final stop where you catch everything. But you don't have to think of it this way.
But I mean, ConfirmClose is also a transformer in that sense, in that things are getting turned into failure objects. Is that right?
Yes, but a more narrow type of transformer than handle is supposed to be.
I mean, the difference between enclosing
targeted,
confirm,
Sorry.
the difference between this and enclosing confirm is that, I mean, it is less about I think is more about like the sort of it's more about the sort of usage, right? Confirm and enclose again is more like optionals, where you're just sort of you're basically just saying if you put a failure into my little block of code here, it's going to spit another failure out, right? And of course, or if you throw an error, some sort of error into my little block of code, it's going to throw another error out the other side. This is more about generalized, generalized exception throwing and catching. And one of the things that it does is it detects, messages and aborts, which is, which happens to coincide with what confirm and close also can do.
Right. Right. And so if I can just offer my experience of recently using confirm and enclose, right? So, so in sort of my main input processing down value that I wrote, right? Basically, the most of it is inside of a single confirm and a single enclose. And then like this thing, which I know can issue a message, but otherwise is fine, is in the ConfirmQuiet. And this thing had better return, a list of two things, or I'm dead. So that's in a confirm, et cetera, et cetera. And I could have done all of that before. And what I would have done is I would have had a big catch, and then every other line would have been if bad thing happened, throw error. And instead, now I just have confirm, I have enclose, and then ConfirmBlock, ConfirmBlock, ConfirmBlock. And it's, sort of automated that workflow. Handle is sort of trying to be more general than that.
Right.
And there is one more thing very important to mention about handle. We plan handle to be very tightly integrated with the exception system that we plan to introduce. And that will simplify things and make them more robust for those who use exceptions.
Okay, let me make a separate point, which is probably for Aubrey. I don't think Brenton in the Code Assistance project has thought about code suggestions that involve adding confirms, but that seems a useful thing to do. That is, it would be nice to have a code assistance that you can run on a WFR that will suggest where you might put, confirms. Does that make sense?
Yeah, I can discuss that with him for sure.
Okay, all right. So let's go back. Okay, Connor, where did you want to go next? I mean, you're talking about handle, and I think we understand roughly what the concept of handle is.
Yeah, and we're I mean, in our again, our rough agenda for this meeting, we weren't really hoping to get deep into handle because it's a hairy problem, and we'll have time in the future to go more into that. But we were talking about categorization of messages, which, as I was saying earlier, is our long-term, our vision is that raise and handle are going to be, a programmer's first tools that they reach for in their toolbox for doing error handling. Now, obviously, for practical reasons, we have a lot of functions that issue messages, so we need to be able to deal with messages in a coherent and robust way. And to do that, we need something like handle that lets us respond to individual messages, but also hopefully some level of automation, some level of categorization of, this message always if this message always represents a failure. We don't want people who are trying to write robust code to have to, repeat, every time somebody writes a piece of code, we don't want them to have to spell out their own list of specific messages to handle.
Sorry, can you can you move that notebook, the Untitled Notebook, out of the way slightly?
Yeah, sorry about that.
Okay, so your proposal is that instead of the raise thing is the modern version of a message in the sense that it simply raises this exception-like thing without necessarily printing anything. Correct?
It's control flow.
Yeah.
Yeah.
Yeah, that's correct.
Okay.
Yeah. And handle is the thing that obviously handles when something goes wrong. And it's first the primary thing it's going to handle are things that have been raised. But it needs to handle messages as well, since there's just so many functions that issue messages. And we were discussing a bit in our prep meeting this morning, and we're hoping to get into this today, a bit about these questions around how do we provide a level of automation so that, if there's a mess, we were going into some examples. Let me just.
Yeah, okay, but I've got a question here.
Sure.
In the current world, in the world of the future, you think that user code will generate raises, as opposed to user code, could generate messages too. But are you imagining a future world in which system functions also generate raises?
So that's yeah.
That's probably the most controversial point.
Yeah, that's got to be the most controversial thing in here, and we're pushing that to what was previously phase 3 and is now phase 4, where because that's kind of a question of convention, right? Is it our convention that public functions, system functions or top level functions and non-system packages, can they be allowed to leak uncaught raises outside of themselves? And we obviously don't have that convention now. There is a desire to have that convention, but there are obviously
so there are different. Okay, yeah. But but the point might be, the message mechanism is 35 years old, and it does quite well, but it is also very human oriented. That is, it's intended, generating a message that a human will read. Right? The idea of automatically handling messages was not really something heavily imagined when the messages system was built. Okay, so an alternative way to get there from here would be to say that system functions which generate messages, that we would basically do a curation pass going through and saying, well, that function generates a message, but it also should generate a raise. And the raises will be like more computable messages, basically. Because messages are not very computable, and that's what we're about to discuss. Right? In other words, a message, one could imagine a situation in which a message generates an association that has all kinds of categorized things about how important it is and what kind of, this, that, and the other, rather than just saying, the cat is out of the bag in words for a human to read.
Yeah.
Yeah, and that's exactly part of the problem. And the other part is that messages typically do not stop evaluation, they continue. And exceptions will alter that part as well.
Right.
Which I think is good.
Right. But it could be the case that what we want to do is the following thing. Every single place in our internal code where we generate a message, have that same piece of code generate a raise, but that raise would be a computable message in which, over time, we have an association that is associated with every, messagey, exception-y type thing that contains data/metadata that is filterable by handle in some organized way.
Right. And of
course, the consequences of this is that anytime you, have a message, evaluation will stop. So. And I remember.
No.
Yes, that is exactly what it means to do arrays.
Okay, but fine. But then we need some version of arrays. We need some version of it so that it generates the metadata for arrays. But the question of whether that raise is going to be fatal or not needs to be handled by the outside handler.
No, but Stephen,
right.
Itai has raised here is that the way we currently think of exception mechanism and the raise is that it immediately stops any further.
Yeah, I know, but I think that's wrong. Okay, so I think what should happen is, just like the raise should have an association that has all kinds of things in it. Like, is this a type of exception that will guarantee to give a wrong answer, or is it one that just affects the precision of the answer? Is this I don't know what. Let's say there are 20 signals, 20 attributes of every raise. One of those attributes is this is fatal. You've got to stop here. Whenever this raise is generated, stop here. Or another setting of that attribute would be, it depends. This might or might not be fatal. You can, if you wrap a handle around this, all the raises inside that have certain metadata would become fatal.
So the thing is, though, is that I don't know what this. I mean, I don't think this. That's a fine thing to do, but it doesn't solve the problem, which is that, I mean, you'd still have, you know, for example, if I call transpose on a non-rectangular array, presumably that's that's an exception, right? That's what we're saying right now.
Mm-hmm.
That'll call arrays, and it's also arrays where it's guaranteed to give the wrong answer.
Yep.
But so what's it? So is the idea that, okay, there it's going to throw an exception that's going to change the control flow, because that's a big, you know, that's.
Yeah, I'm saying that what should happen,
right?
I'm saying what should happen is, if that is enclosed in a handle.
Right. Okay. So this is related to the idea. Okay. So basically this is related to the idea that we had a while ago of, you know, there basically are raises, but they're off by default, and there's some wrapper or variable you can set that basically activates the raises, and
of a certain type.
maybe
with a
and
certain,
maybe handle is the thing that also activates them.
Yes.
I mean, I think it's useful in some pieces of code to allow for raises. I mean, this is one of the other points here. I mean, this is sort of a phase 4 thing, that it may be useful in some code to allow for, you know, at least in interactive coding, to allow for raises to go to the top and to make that sort of look nice and so on.
Yeah, I agree. Where it comes up with an answer, but the answer comes with a disclaimer, basically.
No. I mean, like you call raise. I mean, like in interactive code, maybe you can have a function that fails, and you just want to say, when this fails, I want you to just completely, you know, fail all the way to the top.
I see. And so rather than just having an uncaught throw, right? Rather than just the rather silly uncaught throw message, it comes out with a nice, you know, pinkened box or something.
Yes.
Yes. I mean, we have part of that right here on the lower left on the screen. I mean, currently the idea is that messages would continue to work as they are, but if you mention a message inside handle, just as you mentioned it inside ConfirmQuiet, it would turn that message into an exception that is then raised and handled by this very handle.
Right.
Now, the other idea of having raises that could somehow be turned on or off, I'm not sure. I mean, we had this last time that if I have a piece of code I test for an error condition, and if the error condition is present, I generate an exception, then I should be guaranteed that the rest of my code is not run under this error condition. Otherwise, I would have to test again and so on. So
okay, but hold on. To me, this is deeply connected to this categorization of messages question, because I can imagine a case where you know, where our messages / raises are curated to have a computable version of the message that has a bunch of attributes, and you say anytime there's a message of this type, you know, with this attribute generated, then break the control flow.
Right. So the question is, though, that if we allow some exceptions to break the control flow, then how does this? I mean, like, okay, option 1 is exceptions always break the control flow. That when you call raise, it's always going to you know, immediately raise, et cetera, et cetera. And we're sort of saying, well, there's some situations where you might not want that or something. But then the issue is that, or there's some situations where it's too you know, different from current behavior, et cetera, if raise throws an exception. Oh, but then there are also other situations where, yes, raise should throw an exception that sort of, you know, breaks control flow and so on. And so it's sort of like, you know, if the issue is that it's we can't have exceptions that break control flow, but sometimes we can. I don't understand.
Hold on. Why aren't we just doing the following?
Could I try to jump in here? I mean, so okay, from the developer perspective, and I think this is a very important thing, the function called raise should be consistent in how it behaves, and it should be reliable that it begins. Fine.
So we need a soft raise.
Right. And I was thinking, while we're talking, we need advise, right? This would be the computational alternative to messages. where we'd have something like,
Yeah, that's a nice name, but it's fine. It's soft raise, basically.
right. So like, wrong. The wrong button. Okay. We would have advise, which is not raise, but could trigger control flow if something is listening to that, thing has been advised. Yeah. So like advise, what was one of the examples? I think we had
the transpose has gone wonky.
Right. Transpose has gone wonky. And this would be computational. You could imagine there's something in here that adds, it could have a stack trace, it could have
no, but much more importantly, it has a computable version of the message, because messages, just to remember the history, messages were designed to be read by humans. That was their only consumer 35 years ago.
Yeah.
Okay, then we added, check was an attempt to have a computational consumer of messages that's pretty weak. And ConfirmQuiet is the next level of computational consumption of messages.
Well, we also have message object for transferring messages between kernels. Right. I mean, Roman can correct me, but I believe that's how messages are transferred between parallel kernels.
Well, no, I mean that just happens on the level of the mass link communication. I mean, message generates
a message packet,
which I then just forward to the front end. I mean, I'm not concerned about messages on the remote kernels, but anything other than any normal control flow needs to be caught on the remote end so that it doesn't escape the.
Right.
But
we do have other things that don't use WSTP, like Amazon. What is it? Remote batch
submit.
Evaluate that.
No, remote batch.
Yeah, but that's bad. That's not interactive. So that would be one case where messages are not for human consumption, right?
For which case?
Well, if you want something in batch mode, like remote batch submit or so. I mean, then...
I know, but I don't think we have very good handling. I mean, I think we are basically saying, look, check from like 30 years ago or more is basically a thing which attempts by name of message, although it's never worked very well. And then we tried to have buckets of messages, and that never worked very well. Right? And that's, I think, what we're. So, I mean, just to summarize roughly here, people are saying raise has to be a deterministic thing. Fine, given that name, names are still subject to change. Advise is you can take the advice or you can not take the advice. Okay.
Yeah, and as a programmer, importantly, you would understand that if you do this has no effect. No, it's not going to always have an effect on control flow. Yeah,
right.
You ought to have alternative control flow handling.
If you care about the control flow, as opposed to just, oh, by the way, for certain uses, this might be a horrible thing.
Right.
Because you as a programmer might be saying, look, the case where this becomes a null list or something is like, well, if it happens, if they specified that, then they get what they asked for. But then it could be the case that at the outside, you say, oh my gosh, if it becomes a null list, we're dead. And so we've got to protect against that. Can you remind me what create error type and create failure are?
Okay, so create error type, it registers, you give it a symbol, you give it a set of kind of parent error tags that this will expand into. Okay. Create error type is directly related to create failure. Let me just show the example. This is probably the quickest way. So you give create failure a tag that you've registered using create error type, and it spits out a failure object that has the parents that were associated with that error type and the metadata you provide. So it's a lightweight way to add something like inheritance to failures, so that a file error is an instance of an IO error.
Okay, so
and
this
by
is
the way, I
part
imagine that's how you would that's by the way how you would if you had some distinction about fatal errors, which I'm not sure is ever possible to do, but if it is possible to do, then I think that's how you would do it.
But I claim that what we really want is some very elaborate multiple inheritance thing, because I claim that there are 20 different signals or attributes that there might exist for a message. It isn't just, I mean, conceivably there are families that simply inherit from others, But I think the more relevant thing is that there are properties, attributes, whatever, of different messages. And I think that's what we wanted to talk about before with categorization of messages. Let's explore that question if we could.
Right. So the create. I'm sorry, I forget what it's called. The create error type. Yeah. So that does allow multiple inheritance, does it not?
Yes, it does.
It should.
But,
yeah.
But actually, I wanted to comment on what Steven just said. I think that the question of inheritance between these error types, which are new errors, and the question about categorization and elaborate categorization of messages, they are very related, but it would be best if we still treat them somewhat separately. In that the error system that we're suggesting is supposed to be for, when people just throw certain kind of errors. And for the messages, we may need something actually way more elaborate if we want to categorize them. So I wouldn't.
Look, but Leonard, I think that the main issue here is there's a transitional phase. So first thing is we support for user code sort of computable messages. Then we have a separate project that gradually starts to make messages because what's it going to actually look like? What it's going to look like is we've had message documentation for 30-something years for some messages. I don't know how well that's been maintained because it's not clear people really care that much about it. Okay, the idea here would be that in the end, if we have computable messages, that in a function like transpose, there will be a section of the documentation which simply lists all of the raises that can happen, all of the advises, whatever that can happen inside transpose.
Yeah, there is no question about it. The question is whether the part of our suggestion regarding error types can be developed and employed in the
I don't
new.
know. Yeah.
Like whether they can be fully orthogonal or one strongly depends on the other. And
no,
I
it doesn't depend. Yeah, go ahead.
Yeah, our opinion, I think I can speak for many of us in the error handling group, is that we try to structure things to be fully orthogonal to each other. In other words, discussing this error types, at least the general framework for error types right now, will not prevent us from, in parallel or later, categorizing messages with some elaborate scheme.
That's
and
fine.
Making this mapping.
That's fine, but I think we've already got, I mean, how many messages are there in the system? 5,000, 10,000 messages of that order? Anybody know? It's of that order. Okay. Yeah. That already gives us a lot of data on what kinds of things we're going to need to categorize. So even though we may not get to it immediately, but I think the way to think about this is gradually in version 14, 15, whatever, gradually functions will start getting, it reminds me so much of these horrible Fortran documentation things, a list of possible sort of error conditions that they can generate.
Absolutely.
Okay, which we haven't had in the past. And some of those conditions will be things that some people might say isn't really an error. Like it could be, oh, this inverse is ill-conditioned. Well, some people might say, well, so what? Or another thing would be this inverse. Here's a good example. Here's a good example. Let's say these eigenvalues are degenerate. Okay, to many people that is not an error. It's just the way it is. But to some people, that might be an, oh my gosh, if they're degenerate, the rocket is going to blow up type thing. Okay. And you might say, well, check whether they're degenerate separately, but maybe this isn't the best of examples. But I can imagine a case where that is it's a piece of advice. By the way, these eigenvalues were degenerate. Okay, so it generates an advice, but it doesn't generate, that wouldn't even raise to the level of being an error in the sense that we've had them previously. It's kind of like an off by default message type thing.
Yeah, but just more computable. Yeah.
Yes, but it means that there's something funky that happened. And even though we wouldn't have made that, even a message, it's not dramatic enough to even be a message. you know, that's a thing which could be listed in the documentation as one of the things that can happen with this function.
Yeah, absolutely. I
Right.
can't.
Okay.
Yeah, sure. That's a great idea. Absolutely. I'm just saying it's somewhat. It's a somewhat separate topic, which we can obviously also go into.
It is, but it's just that we have an awful lot of data, because we can have a lot of theories about what messages, what kinds of exceptions and so on are going to be relevant in user code. But we already have 10,000 examples or whatever it is, right? So we should be looking at those, because those are 10,000 examples of pseudo that didn't happen to be user code, but it could have been type thing. So, okay, let's go back onto categorization of messages if we could.
Sure. I'm going to make a note about what you just said.
Yeah.
Okay, sorry. So categorization of messages. Did you want to lead in with a question?
Well, I want to start talking about that. I mean, okay, so first point is, I'm pretty sure that there are 20 attributes. Okay, and I think the idea to reduce it to like 3 is wrong. Let's start listing what some of those attributes might be.
So potential attributes of advisements, perhaps?
Yes, right.
All right.
Sorry, is an attribute like a field in an association?
Yes, it's a field in an association.
Type.
No, it's a field in an association. Potential properties, we could say.
Right. Well, there's definitely.
I would imagine that
that's unbounded, but
yeah.
The question is, are there properties that are?
No, but it's not unbounded. It's important that it's standardized, because the handling of these things is, it's like it is. This is an interesting point. Okay, how unbounded should it be?
Right.
Because most code is going to say, okay, if it is a severity level above 2, if we had severity levels, which I do not recommend, but if we had that, we would say if it's severity above 2, error out, otherwise don't.
Look, I mean, I think the thing is, it's a unhappy code is unhappy in many different ways. I mean, if you have like pretty much if you look at messages, right. If you look at messages and you look at what parameters each message takes, right, which is sort of a proxy for these attributes, they take lots of different things, because there'll be something like, oh, it's a file IO error. Okay, maybe all file IO errors should include the path to the file that you're struggling with. Fine, but then there are things like, oh, it's a compilation error, and there are 500 different ways the compilation could fail. I mean, oh, the function that you tried to call doesn't exist. Okay, you give the function you tried to call, as an attribute. Oh, the type signature of the function you tried to call is wrong. Oh, so many different things.
So look, there's an empirical thing we can do, which is, let's take all the messages in the system and let's look at this question that you asked. What parameters do they take?
And probably not just all parameters they take, but all parameters we would like to provide to them in principle if we redo this.
Well, yeah, right. But I mean, but the thing that Christopher is pointing out is that there's already
what I'd imagine is that there's a small number of these error classes, right? There's a maybe relatively small number of these error classes. Like there are 20 core ones. And which have standardized attributes. So all children of that class have to provide, all children of the file IO error class have to provide the path or something like that, right? There maybe are like 20 of those. Then there's probably, maybe these aren't documented, but there's probably one of these for each packlet. Like for every package will have its own general error for its world. And then below that, there are probably, the actual number of errors as opposed to error classes is probably huge. So you probably have like 20 things at the top, and then they're all very high degree, and there's just a billion things underneath at the leaves.
Well, this is exactly what we need to do. Okay, so look, who can do we have access? Let's see. There used to be actual documentation. There used to be a little booklet, which was a collection of errors. It was created by Dave Witoff. Do we still have that? Do anybody know?
There's probably there might be a guide page for all the message documentation.
I don't think there
Not
is.
sure.
There used to
Yeah.
be an actual
Yeah, I don't think. Well, you can
try
look if
search
there
for
are
all
any
pages
links.
involving messages.
Yeah. Messages guide.
Warnings and
it's-
messages tech note. Warnings and messages tech note. That was the one. I
Whoa,
think.
okay. Let's,
Oh no. Well, okay. It might be. I mean, I think have a copy of it somewhere. We have this little book, which is hundreds and hundreds of messages.
Right, well, all properly written messages are in one file, which is, I can tell you how long it is. It's probably 7,000 lines long.
Okay,
Where
so
is
my
that,
guess
Itai?
of 5,000 to 10,000.
what file is that?
That's airmessage.m.
But where in the kernel? I'm just looking for it so I can open it up.
Well,
I think it's in its own repo, isn't it?
Yes.
Oh, I might already.
I mean, if you want the one that's in the layout, then it's in.
But let's understand error messages. That workflow at the bottom that might contain information.
Understand. Oh, okay.
Right. So
I
currently,
think these are all just.
Okay, so I need to subtract off 3 lines for the initial count. There are currently exactly 8,500 messages in airmessage.m.
Wow, I was pretty good in my 5,000 to 10,000. Is that a good estimate, or are there more in Packlets?
There are more in Packlets, although those are generally not localized. So
on the order of 10,000.
Yeah.
Okay, so what we need to do is start breaking these down into buckets.
Actually,
So where is that file? I just want to pull it up.
in the layout or in source?
Anywhere that I can find it most quickly.
It's I believe it's messages.m in contents, system files, kernel, I believe text resources messages.
One thing I wanted to mention is that those buckets may not necessarily be disjoint.
Which bucket?
That's the one.
Buckets of messages that you, Stephen, plan to put those messages
Of
into.
course they won't disjoint. That's why I'm saying they aren't buckets.
Yeah,
if it was a
exactly.
bucket, they're just properties, right?
Yeah.
It's not buckets, it's properties.
Yeah, and they will actually, they could potentially map quite nicely into error types that we are defining in this error system with multiple inheritance. So that's where
I don't believe in types in this regard. I just don't believe in it. I think that this is, okay.
Well, the type is mostly just a tag. So
I know, but so what we need to do is take this list. Okay, and again, please, let's find the old booklet about messages, which describe, have a paragraph. I think they even have examples for a bunch of these messages. Okay, let's get a sense.
Do you have any? Do you have any keywords that I should use if I'm looking for that? I mean, book of messages, but
you know what? I have a copy of it someplace. I just have to find my.
I'm sure you do, right? It's the finding it.
Well, no, I mean, I just rearranged all of my Wolfram language books because they had overflowed.
Wait, do you mean a physical book of messages?
Yes, I mean a physical book.
Okay.
Yeah, we used to actually sell books.
All right, I'll be right back to it, and I have to go soon. But I think I can probably find this. Hold on one second.
Yeah, a lot of the things that are now like the longer like monographs or like tutorial collections. Those used to be sold as physical books you could purchase. For version 6.
Yeah, that I knew. I'm just surprised that there was a dedicated book of just messages.
I did not know that either. That is a little bit surprising, but it does seem like a very David Widoff sort of thing to do. So on that level, given that the author cited, I'm not shocked that this thing exists.
Yeah,
it's a very no fun book. You want to see the book of all the cool functionality. This is all the book of pain and failures.
Right.
Why are there messages for private symbols in here?
Oh.
Probably.
No, they're aliased.
Yeah.
See, it's
right.
It's also orthogonal.
Oh yeah, I see. Okay.
Yeah.
Yes. I mean, this list itself is something that we should. There's probably a lot of things that
can't
could be
find it.
combined into
Huh?
into more general messages with more parameters.
But wait a minute. Did you stop sharing, Connor?
No, I'm still
We're
sharing.
still
I
sharing.
still see your screen.
Oh, okay. What happened to?
Now, I did want to say, so I just put these random strings in here, but I think, to me at least, it seems obvious that this would, because we're talking about doing this programmatically, this would be a tag like we're using with create failure. And potentially that even means rather than create error type, we might have a more generic, create tag or something. And I think this system already supports, it's not a strict type hierarchy, right? It's just a collection of loose tags you can have multiple of.
Guys, I'm telling you what's going to happen, which you're going to discover as you start looking at these actual messages. Okay, because these messages are a proxy for exceptions. Okay, by the way, I looked for this book. I don't seem to have it, but immediately at hand, it is a purple and white book of the same series that we had, things like Guide to Standard Add-on Packages. And if all else fails, Dave Wittoff would be able to find it because he wrote it. Okay.
I have it. I've got it right here.
What is the title?
From Mathematica 2.1.
Okay.
What is the title, Todd?
It says Mathematica. I just put it away. Mathematica warning messages. It says technical report. Mathematica warning messages.
How thick is it? How many pages?
Let's see. It's it's like a third of an inch. It's 350 pages.
Wow. I presume there's more than just a message text. There's
No, there
explanation.
isn't. Yeah, there's explanations.
No. Yeah, but it's on. It's just a list
That's
of
the one.
tags and the messages that apply to them.
That'd be funny if it's been scanned. Wow, really? Well, maybe we can find it from there. Anyway, we can clearly get this. There's clearly an online version of it. I mean, there's clearly I'm sure.
Worst case, someone in Champaign can go to the 5th floor and pull it off of a bookshelf.
Yes,
Yes.
I'm actually not in Champaign today, but I was going to offer my services as somebody who can actually go into the library and find physical books.
Yeah. Now, right, we do want to wrap up, and I think Stephen, you wanted to make a comment about categorization and types. And
Yeah,
all that.
I think there's a very important exercise to be done, which is to go look at these. Sorry, what is this thing called? It's called Mathematica warnings and messages. Is that right?
Mathematica warning messages (parentheses technical report). That's what it seems like.
Messages. Hold on one second. Let's see if I can pull this up. I have the version 2.3 development plan, which contained enhancing that.
We should make sure that gets back on the agenda.
Yes. My God. Oh, this is kind of interesting, actually. This has the.
Do you have it? Should I share, or do you want to share?
Well, I could hear. I can just send it to you. Hold on one second. Let me see. I could just send you a message here. I need to go in a second here, but I just want to. Oh, come on. Well, actually, it wasn't as easy to do this as it might have been. Never mind. Well, okay, here, let me just share for a second. Here.
Right. There you go.
Version 2.3 development plan. My gosh, look at that one. Well, that's back on the agenda. Well, look at this. Implement special data structures for numerical matrices. We just are doing this now in 13.1. Extend the compiler to handle lists and compressed matrices. Okay.
Well, that's basically done.
Yes.
Maybe we should just, just add a, add just to make it, this is the 14, 13.3,
right. Get a little bit of whiteout. Be good as new.
Yeah.
right.
Update this. Okay. I'm sure I have this in my someplace in my archives. That's what I think. It's very likely. My gosh, I have a well, anyway, I mean, I'm pretty sure I can find this. We're sure it really is called, you physically have it in front of you, Todd.
Yeah, it's called Mathematica warning messages. It's a technical report at the top. This is the blue before we went to purple. This is the blue version.
Oh, it's a blue version before purple.
I just want to mention briefly, I know, Stephen, you're going to have to go in a minute, but if other people could stay back, there's one last thing I want to talk to people about that's not relevant to this meeting.
Okay. Well, here, you can reshare, Connor.
Sure.
Okay, but I think the next important thing is to go through and start looking at how would we classify, what attributes, what properties do we want to identify in these messages?
Right.
Okay, because that's, go ahead.
Yeah, another question is, there are obviously messages that we consider fatal, like wrong number of arguments or so. So if we look at code, then probably there would always be an if statement following one of these things that check for certain error conditions.
Yeah, except most people don't check. That's the problem. That's what we're dealing with. So I think categorizing, if we've got 10,000 messages, we'll probably be able to have, some of them are generic, general : messages. This is a project to do. This is, making messages computable. We've made many other things computable. We'll manage to make these computable, and then we'll be able to, do logic based on those messages. And I need to run. So I think we need to end this. Well, we should probably say goodbye to our live stream participants and continue this another time. Okay, I'm going to